Honda all-terrain vehicles are a reflection of the Honda philosophy to stay a step ahead of the competition. Honda ATVs are the best on earth. Now, sometimes this poses unique challenges for Honda service technicians, testing your diagnostic skills with new emerging technologies and providing the rare opportunity to set the service standard for the rest of the industry. So today we're going to sharpen your skills as a Honda technician with useful information from Honda Technical Services. We're going to take an in-depth look at the electric shift program, or ESP, found on the Honda TRX450 ES. Now, the electric shift is also on the TRX450 FE and TE with minor differences. But for today's program, we'll be primarily concerned with the TRX450 ES. After watching this program, you'll be able to identify and locate the key components of the electric shift program and their connectors. You'll also be able to describe how the ESP functions and how to troubleshoot two of the most common complaints. In a few minutes, we'll get into some detailed diagnosis and repair procedures. But first, let's take a look at the components of the electric shift program. The electric shift program consists of several components both inside and outside the transmission. The shift switches are located on the left handlebar. The upper button is for up shifts, the lower for down shifts. The shift switches are connected to a 3-pin connector and link directly to the electronic control unit, or ECU. The connector is located under the right front side of the fuel tank. The reverse switch is located near the rear brake lever. This switch is activated by pushing down the reverse button, then pulling on the rear brake. Then it will shift into reverse from neutral when you push the shift down button. The reverse switch uses a 2-pin connector. The electronic control unit, or ECU, is located under the front fender, attached to the center of the frame. On the left side of the ECU, you'll find a 5-pin connector. On the right side is a black 16-pin connector. The ECU triggers gear changes through a shift control motor located on the front of the engine. Depending on the current from the ECU, the shift control motor rotates the sub-gear shift spindle for up and down shifts. The shift control motor uses a 2-pin connector located here on the frame, which connects to the ECU. Right next to the shift control motor is the angle sensor, which is also connected to the sub-gear shift spindle. The 3-pin connector is attached directly to the angle sensor. The angle sensor is one of the most important components we're going to cover today. As I mentioned, it is connected to the sub-gear shift spindle, so every time the shift control motor turns the spindle for an up or down shift, the angle sensor detects the direction, angle, and speed of the rotation and converts this information into a voltage change that is output to the ECU. At the rear of the crankcase is the gear position switch, which uses this 4-pin connector and grounds through the engine. The gear position switch not only prevents the vehicle from being started when it's in gear, it also completes the circuit for the indicators for reverse, neutral, first, and 5th gear. Now, you might be wondering why the gear position switch doesn't control the indicators for 2nd, 3rd, or 4th gears. The ECU determines when the vehicle is in 2nd, 3rd, or 4th gear by inputs from the speed sensor, engine speed, shift switches, and angle sensor. You should be aware TRX450 FEs and TEs are a little different than the TRX450 ES. The 350's gear position switch does have positions for all the gears, and the 350's ECU does not run the display. The display is controlled by the gear position switch for all positions. On the 450, think of it this way. The vehicle is in neutral, so the gear position switch enables the starter relay switch, and the vehicle is started. Next, the driver shifts into 1st gear, and the gear position switch sends another signal to the ECU. When the transmission shifts into 2nd gear, however, it's the angle sensor that confirms the shift with the ECU, not the gear position switch, and the same is true for 3rd and 4th gear. In fifth gear, the gear position switch sends another signal to the ECU, letting it know the transmission is in top gear, which prevents any further upshift attempts. The ignition pulse generator is also located at the rear of the crankcase. Its connector is located under the right side cover, and it sends an RPM signal to the ECU. The speed sensor is also located at the rear of the crankcase. It uses a 3-pin connector to the left of the gear position sensor connector. The speed sensor sends a signal to the combination meter as well as the ECU. And of course, power to the ECU comes from the main relay, which is located under the seat by the battery. The TRX450 ES is currently the only electric shift model that uses this main relay. The TRX350 FE and TE do not. When you put it all together, the electronic shift program combines the ease of an automatic transmission with the performance of a manual. Gear shifting is done sequentially. Push the upshift button once for each higher gear, the downshift button once for each lower gear. The ECU controls every shift function, using real-time sensor input to calculate exactly when to disengage the clutch, shift gears, and then engage the clutch. The electronic shift control motor engages the clutch at different speeds for optimal performance. And information from the angle sensor helps the ECU determine when the gear selection, either up or down, has been completed. To protect the engine and transmission, the ECU is pre-programmed not to operate within certain parameters. For example, the system will not allow shifting from neutral to first when the engine is running above 3,000 RPM, or the vehicle is traveling at speeds higher than 6 miles per hour. And the system will not allow downshifting to neutral at speeds greater than 2 miles per hour. ES models also come with an emergency manual gear change tool that can be used in the event of an ESP system failure. This gear change tool is included as part of the toolkit and is stored in the tool case. Operating instructions are in the owner's manual. After using the manual gear change tool, it's necessary to reset the system by cycling the key off, then on. Certain failures may not allow the system to reset. When diagnosing a shift system failure, do not use the manual gear change tool before checking the angle sensor, since that will change its position, making it much harder to diagnose. Sometimes it's necessary to rock the vehicle slightly while pushing the shift button to get it into neutral. Okay, now that we know how the electric shift program functions, let's move on to the diagnostic issues. When the ECU detects a system abnormality, its built-in self-diagnostic feature will disable the ESP. While this sounds fairly normal for any type of electronic control unit, here's the tricky part. This particular ECU does not generate a fault code or let the technician know where the problem lies. It's also important to understand that every time the ignition is turned on, the ECU conducts a pre-operation system test, or POST. If a defect is detected during the POST process, the system will go into the failure mode immediately. You can identify this by the horizontal lines on the meter display. Likewise, if the system detects a problem during operation, it will also go directly into failure mode. Understanding exactly when and how the vehicle goes into the failure mode is perhaps the most important step towards successful troubleshooting. For example, if you're able to reset the system by turning the key off and on and execute at least one shift using the ESP, then you can assume the ECU is working and the defect that triggered the failure mode is coming from one of the other ESP components. However, the most challenging scenario is when the ESP does not function at all, even after you turn the ignition off and on. The challenge with this scenario is to determine whether or not the ECU is truly in the failure mode, or if the ECU is not receiving some or all of its required inputs. It's also possible that a customer will experience a problem with the ESP, and when the vehicle is brought into your shop, it works just fine. In this case, It's important to do your best to identify and then recreate the conditions that caused the failure in the first place. Start by asking the customer about the riding conditions when the failure occurred. How long were they riding? What gear were they riding in? Were they running at a high or low RPM? What kind of terrain were they in? And it's always a good idea to test ride the vehicle to duplicate the failure. Here's a tip. If you happen to get a situation where both the neutral and reverse lights are illuminated, check the main fuses. Chances are you'll find a bad one. As I mentioned earlier, an understanding of how and why the ECU has gone into the failure mode is the most important step in troubleshooting the ESP. Next, let's take a closer look at the most common complaints with the TRX450 ES, which is when the ATV quits shifting during operation. That's probably the most common complaint. First, take the emergency gear change tool found in the toolkit and shift through the gears manually. This will help you confirm that the transmission is mechanically sound and not the source of the problem. Remember, as long as the ESP function is restored for even one gear shift, we can conclude that the ECU is working. And since the ECU does not provide any kind of status information, this is the only way we can conclude that the power supply and ECU are in good working order. The most important criteria in troubleshooting this complaint is to determine if the ECU is resettable. The ESP function can be restored by turning the ignition key off, waiting a few seconds, and then turning it back on again. If the ECU is resettable, the problem is most likely with the angle sensor or speed sensor. If the ECU is not resettable, the problem is most likely with the shift motor, angle sensor, or other components or switches. If the ATV stops shifting during operation, but the ECU is resettable, a good place to start your troubleshooting is with the angle sensor. Because there is a small amount of play between the two gears, the ECU has been programmed to allow a certain amount of slack or tolerance in the values received from the angle sensor. However, if the resistance at the angle sensor exceeds these preset values for any reason, the ECU will immediately go into the failure mode. With the ESP in the failure mode, disconnect the angle sensor connector. Remember, if a customer has shut off the key and used the gear change tool, the angle sensor has been moved and the system could be reset when the key is on. This is why it's important to troubleshoot with a vehicle in the failure mode. The angle sensor rotates with each up and down shift and rotates back, returning to its center position. Check the resistance between the center and both outside terminals on the angle sensor. The normal reading is approximately 2.5K ohms for each reading. If the readings differ from each other by more than 900 ohms, the angle sensor is defective and must be replaced, just like this one. It is outside spec and needs to be replaced. That's the most likely fix for the most common complaint. But what if the angle sensor had checked out okay? Then we'd move on to the speed sensor. In some cases, a failure may occur when the vehicle is ridden at a high RPM for an extended period of time. If this is the case, inspect the speed sensor and its connector, since it's possible for dirt or moisture to penetrate the connector and cause problems. If you find contamination, clean the speed sensor connector with contact cleaner and coat the terminals with dielectric grease before reconnecting. If you don't see any contamination, remove the speed sensor for testing. First, remove the two bolts and the speed sensor. Inspect for physical damage. If there is none, connect the inspection adapter as shown in the service manual. Check the input voltage with the key on. Connect your voltmeter between the red wire of the adapter and ground. You should have source voltage. Next, measure between the green and white wires of the adapter. The voltage reading should repeat from 0 to above 5 volts as the sensor shaft is rotated. If there is no output voltage, the speed sensor is faulty and needs to be replaced. Reverse the removal process to install the speed sensor. If it's not the angle sensor or the speed sensor, It's possible the shift buttons could be malfunctioning due to the intrusion of dirt and water into the switches or their connector. A malfunctioning shift button will cause the ECU to go directly into failure mode. After visually inspecting the switches for dirt or debris and having removed the front fender, lift the fuel tank and disconnect the connector. Check for continuity between the black-red wire at the shift switch connector and each of the other two wires. Check between the white-blue wire and the black-red while pushing the upshift button. You should have continuity when the button is pushed and no continuity when the button is released. The same goes for the downshift button between the white-yellow wire and the black-red wire. With the switch disconnected, you can also jump the circuit to see if the ESP will shift without the switch. Jump between the black-red wire and the white-blue wire for upshifts and to the white-yellow wire for downshifts. If any tests show a defective switch, replace it. We've just covered the most likely repairs for the most common complaint with the electric shift program. That's when the ATV quits shifting during operation. We specifically covered when the ATV can be reset by cycling the ignition key off and on. This is by no means a solution to all ESP problems you might encounter, but it's where you should start to save yourself a lot of time and aggravation. Next, we'll troubleshoot a complaint where the ESP does not operate at all and the ECU cannot be reset. This is the most challenging scenario when it comes to diagnosing and repairing the electric shift program. As we covered earlier, the TRX450 ECU is unable to generate any type of fault code or signal that would help identify the problem. So when you have a vehicle where the ESP does not function at all and will not reset when the ignition is turned off and on, you must determine whether or not the problem is the ECU itself or one of the other components. What you do know is this: the problem is either a defective ECU or something that causes the ECU post-process to fail immediately before a shift is executed. So, where do we start? Like any good detective, we begin by ruling out suspects, one at a time. First, start with simple checks of the fuses and the battery, since a low or dead battery will cause an ESP failure. Next, use the gear change tool to make sure the transmission is mechanically sound. Now, we need to make sure the ECU is getting the power it needs to do its job. We can do this by back probing the ECU with the key on, making sure the input voltage matches source voltage. Be sure to apply dielectric grease to the back probe and match the curvature of the back probe to the curvature of the outside of the wire. Using the back probe adapters, start by checking the input voltage between the red-yellow terminal and ground with the key on. If this voltage reading does not very nearly match source voltage, we need to go back and find where we've lost the voltage. It could be the fuse, the main relay, or the wiring. If it does nearly match source voltage, then we can move on. Next, back probe the black-green connector with the key on and verify once again the voltage nearly matches source voltage. Here again, we find a difference between the TRX450ES and the TRX350FE and TE. For example, the 350s do not have a main relay. They get their power from the 30 amp fuse box. It's hot all the time and doesn't need the key on to probe for voltage on the red-yellow wire. Okay, the input voltage is checked out, but before we conclude it must be the ECU, we need to check the other components. If we had a defective shift motor, we would be unable to reset the system, so that's a logical place to go from here. To check the shift motor, disconnect the 2-pin connector, remove the motor, and connect it to a fully charged 12-volt battery, and see whether or not it turns. If the motor does not turn slowly, or displays any other abnormal signs, repair or replace it. You can repair a flooded out motor by disassembling, cleaning, drying, and reassembling it. Now, if the motor tests okay, disassemble and clean the reduction gears, Applying grease to the reduction gear and shaft as detailed in the service manual. Use the recommended Unirex N2 or N3 grease available through Honda. For more details, refer to the April '99 issue of the wrench. Reinstall the reduction gears by aligning the punch marks on the reduction gear with those on the gear shift spindle. Install the dowel pin and a new O-ring. Then install the control motor. Tighten the 2 bolts and reconnect the control motor 2-pin connector. Now, if you've gotten this far and still haven't found the problem, it may be necessary to continue testing all the components one by one to find the problem. At this point, you should inspect the angle sensor, measuring the resistance using the procedure covered earlier in this program. If the angle sensor checks out OK, move on to the speed sensor. From there, you may need to extend your search to the gear position switch as well. Keep in mind that the gear position switch only sends a few signals to the ECU. And you should also inspect and test the shift switches and connector as well. Only after determining that all other parts of the system are okay would we test the ECU itself by swapping with a known good part. And there you have it. Here's our problem. As we've seen, if the ESP is not resettable, it is the most challenging troubleshooting scenario for the electric shift program. But by following the systematic troubleshooting technique we just covered, you can work your way through the system step by step to find the problem quickly and then make the repair. Today we've examined the electric shift program on the Honda TRX450 ES and the minor differences on the TRX350 FE and TE. We identified the key components of the electric shift program, described how the ESP functions, and lastly, addressed 2 common customer complaints and their most likely solutions. First, when the ESP quits shifting while it's being ridden, and second, when the electric shift program doesn't work at all. Now, we hope this program will save you some time in servicing the ESP. Thanks for watching.